In this video, we want to look at the operations that can be carried out on polynomial expressions. So we can add, we can subtract, we can multiply, we can divide polynomial expressions. Is that okay? We are starting with addition and subtraction of polynomials first. And to add or subtract polynomials is a simple one. All you need to do is to pick their like terms. Is that okay? You know that polynomial expression is actually an algebraic expression because we have numbers and alphabets combined there. Is that also? So they are actually algebraic expressions. So to add or subtract them, you pick the like terms and work together. Terms that are unlike, you cannot add them, you cannot subtract them. Is that okay? So now the question could be, how then do we identify like terms of a polynomial? Is that so? And the answer is simple. The like terms of a polynomial is simply obtained from the powers of the variables there. Alright, so if I give you two or more different polynomials, they are like terms, you go in there, okay, which terms there have the same powers? Those terms that have the same powers are like terms. We have this example here on the board, is that okay? We have two polynomials, one is p of x, and then the other will label it as f of x. If you look at this is x raised to the power 4. If you come to this polynomial f of x, did you see any x raised to the power 4 there? No. It means that there is no like term of x raised to the power 4 in f of x. In fact, you can say it's 0. Because here, if you want to fix in x raised to the power 4 in f of x here, it's going to appear as 0 times x raised to the power 4. Is that okay? That is why there is no x raised to the power 4 here. Because 0 times any number will give you 0, so it goes off. Alright, so we can rightly say that x raised to the power 4 does not have any like term here. Now let us look at this x raised to the power 3. You notice that I'm not interested in the coefficient, the number that is multiplying them. Is that so? I'm not interested in it, in getting my like terms. So x raised to the power 3. You come over here, do you have x raised to the power 3 there? Yes. That's minus x raised to the power 3. Therefore, this plus 3x raised to the power 3 and minus x raised to the power 3 are like terms. What about terms in x raised to the power 2? This is plus 5x raised to the power 2 from p of x. This is minus x squared. So you look at x raised to the power 2, x raised to the power 2. So this term and this term are like terms. So you can say that. The same thing, the constant, these ones without x, minus 6 and plus 1. Alright, now observe, I've stated x raised to the power 4 does not have any like term here. Then notice something, 2x in f of x does not have any like term in p of x because there is no x raised to the power 1 in p of x. So this is how you identify your like terms. Is that okay? Please take note of this. Go through them. Go through this short note here. When you are working with addition and subtraction, as in fact, generally operations with a polynomial expression, you want to respect the signs and board marks. We have this question and the board want to look at. If p of x is equal to 3x raised to the power 3 plus 5x raised to the power 2 minus x plus 2, and h of x equal to x cubed minus x squared minus 2. Find a, p of x plus h of x, b, h of x plus p of x minus h of x. Now how do we approach this question? It's a simple one. Alright, so to solve, we have a solution here. These were the polynomials given to us, so I just had to bring them out. Then the first part of the question A, we have to find p of x plus h of x. Now how do we handle this? Remember, you pick them like term by like term, you group and then you add. So the like terms we judge based on the power of x. Here you have x raised to the power 3, that's the highest power of x here. And then you notice that in this h of x, you also have x raised to the power 3. So these and these are like terms. You can add them up. So I'm going to say 3x raised to the power 3, then plus, let me write those terms in h of x with red marker. Is that okay? So that's going to be plus x raised to the power 3. Then the next term plus open bracket. We now check for x raised to the power 2 terms. Is that okay? Here we have x raised to the power 2 in p of x, the quotient is 5. Then here we have x raised to the power 2 in h of x, the quotient is minus 1. So you pick both of them. I'm going to write this is 5 x raised to the power 2, then plus, good. Coming to this, remember this is minus. So you want to pick that minus x squared. I already stated in the previous video that you want to respect signs so you don't get into trouble. Is that okay? Then we look at terms in x raised to the power 1. I will come to p of x. Do I have x raised to the power 1 term there? Correct. That is minus x. So I'm going to write minus x. I will add it to the x raised to the power 1 term in h of x. So let's see if we have the like term there. There is no x raised to the power 1 term. Is that okay? So if I like, I can put plus 0. If I don't like, I would remove it because any term plus 0 is that same term. Lastly, we pick terms that do not bear x, that is constants. Then from p of x, we have it to be plus 2, which is 2. And then from h of x, we have it to be minus 2. So you put minus 2. You know, plus 2 is still the same as writing 2. I don't know if you're getting me right. But if it is minus 2, you must show the sign. We can now conclude that p of x plus h of x is now equal to, you come over here, 3x raised to the power 3 plus x raised to the power 3. How do you work around this quickly? Pick their like terms first. This is 3 as the coefficient rather. Pick their coefficient. And this is invisible 1 as coefficient. So 3 plus 1 will give us 4. To be 4, then you pick the common term, x raised to the power 3. Is that okay? Come over to this. This is 5x squared plus minus x squared. The coefficient here is 5. The coefficient here is minus 1. 5 minus 1. You know, plus times minus will give you minus. 5 minus 1 will give us positive 4. Then pick the common terms. Then you come over here. This is minus x plus 0, which is plus, okay, that is going to be minus x. Minus x. Minus x plus 0 is minus x. Then plus times minus, you maintain that minus. 2 minus 2 is 0, so it goes off. Therefore, this is the result of the addition. We're going to take a short break. When we come back, we'll look at the big part of the question. You're welcome from the short break. Now, we want to look at the second part of the question, that is big part. That big part, we have to evaluate h of x plus p of x, then minus h of x. Is that okay? Without solving this, you know that the answer is equal to p of x. What we are going to get, the answer is going to be this polynomial. It's very clear from here, you can see, because here h of x minus h of x will give you 0. I hope you know that, right? Then you'll be left with what? P of x, which is your result. So our answer is actually 3x raised to the power 3 plus 5x squared minus x plus 2. But for clarity purposes, let's just solve it. Is that okay? So this is going to be equal to now we would pick our h of x plus p of x. H of x plus p of x we solve is equal to this polynomial, the result. So I'll write 4x cubed plus 4x squared minus x. This is our h of x plus p of x. Then it's going to be minus h of x. And h of x is what? H of x is giving us x cubed minus x squared minus 2. So we're going to pick them like term by like term and then we'll work around it. Is that okay? So look at, we have x raised to the power 3 and the highest power in this term here is x raised to the power 3. So we can pick it, which is 4x raised to the power 3. Then we'll come over here. Is that okay? You know, if you use this minus to open up these brackets, these signs will change. In fact, let me write it here. This is the same as minus x cubed plus x squared plus 2 by opening up the bracket with this minus sign. Is that okay? Good. So coming over here, we have x raised to the power 3 as a like term, but it's minus. So I'm going to write minus x raised to the power 3 is its like term. You pick that. Then plus, we look for x raised to the power 2 term. Is that okay? Here we have 4x raised to the power 2. Now we'll come over here and pick its like term. Do we have x raised to the power 2 there? Yes, that is plus x raised to the power 2. And then we'll come over here, we have x raised to the power 1 term. We're going to pick it plus, that is minus x. Now we'll come over here, do we have an x raised to the power 1 term there? No. So it's going to be plus 0. Plus 0. So I choose to use different markers so that you see, we pick from this term with blue marker, the other term with red marker. It's not a rule. So don't go and write with different colors of pen. Alright, just for you to see what we're doing, we're picking them. Then plus, lastly, we look at terms that do not bear x at all, which is constant term. Here, is there any constant term here? No. So you're going to write 0. Then you come over here, is there any constant term in this h of x here, that's going to be plus 2. Now we are done, we can now simplify. This is 4 minus 1, then you pick the x cubed. Or is it 4x cubed minus x cubed, which is going to give us 3x cubed. Come over here, plus 4 plus the coefficient 1 here will give us 5, then x squared. 5x squared. And then here is going to be minus x, and then this is going to be plus 2. You see, we've gotten our answer. Compare this thing with the value of p of x, the polynomial, that you see that they are equal. So this is how you handle addition and subtraction of polynomials. It's a simple one. The next video, we're going to look at multiplications of polynomial.